In one of my courses on object-oriented analysis and design, a participant came to me and asked, why is our software architect doing something like this? And he explained the issue. I answered that what he was trying to do was to make his architecture using design patterns about this, what this course is about. Welcome, I'm Onno van Roosmalen. Welcome to this introductory video on this course on design patterns and emergent architecture. For whom is this course intended? Okay. Now, software developers and software architects who want to improve their object-oriented design skills for their software, using the patterns of the Gang of Four. You can see the book here, Design Patterns, by 4 authors that are referred to as the Gang of Four with a wink to the Wild West. They published this book in 1994, I believe, maybe 95, and it is still very popular. It's one of the most popular books in our field. Now, what do we expect you to know already when you come to this course? Well, of course, you should have plenty experience with object-oriented languages like C++, Java, C#, etc. You should also have some knowledge of UML. So you should be able to read and write simple class diagrams so that you can read the diagram that's here behind me. Why do we do that? Because, first of all, it makes the course more language independent. So whatever language you use, it does not matter. And also because the idea is that we raise the abstraction level with which you look at a system, at a software system. Okay. One possibility is that you have attended the course that I mentioned before, Object-Oriented Analysis and Design, that's also offered by the High Tech Institute. And of course, most important, that you enjoy technical discussions, because we will have a lot of them. Now, what about design patterns? You probably know about it or have heard about it, maybe applied some. And you know, or you may not know, but the focus in design patterns is coupling between classes, so coupling in the small. Okay. Also, it helps you, design patterns help you to improve the information hiding and exploit polymorphism. Okay, that is in your program. And very important is that you can make a design incrementally. So you can add various patterns one at a time to arrive at an architecture. So that is the reason for the quotation by Grady Butch. Okay. He said, every object-oriented architecture is full of patterns. And I try to show that. Okay. Very reasonably simple examples that are easy to understand and work with during the course. Now, emergent architecture, where does that come from? Well, that comes from the idea that you make an architecture incrementally, so you can slowly build towards an architecture that you envisage. In architecture, of course, the focus is more coupling in the large. So you look at your components, larger components, and how they interact, couple. Very important here is that you address non-functional requirement. That is actually the basis of architecture, is addressing non-functional requirements. And I want to show that also in the next couple of slides. Because of all of this, it fits very well with agile methods, where you work iteratively towards some functional goal, but also non-functional aspects of your architecture. So let's look at this incremental design idea, okay? So let's look at a spreadsheet where you have cells and you want to add formulas to these cells, okay? So that's a functional extension. Now, of course, you also have to pay attention to the non-functional aspects, the non-functional requirement. So for instance, extensibility. you want your formula to be extensible with all kinds of new aspects, so like mathematical functions, etc. So you pick a pattern. Composite pattern here is a very important candidate, and you integrate that into your design, so you make it work. Now, another non-functional requirement that comes next is performance. Performance can be tracked by virtual proxy. Proxy means that proxy caches some information from a subject. So you integrate that in your design again, so you make that work, and then you go to the next non-functional, so scalability, for instance. So because cells can change, cells may be affected by the change in another cell, so you use the observer pattern. So scalability leads to selection of a pattern, namely the observer pattern. And again, you integrate that into your design. So you make cells observers of formulas. So if an aspect of a formula changes, a cell in a formula changes, another cell will observe that change. And you integrate that again so that you get a full design. Now, of course, there are many, many more things that you need to do to get a real system, but this illustrates very nicely how this can work. Now, what is the content of the course? Okay, so we will discuss all the patterns of the Gang of Four, so out of that book that I showed you earlier. We will also discuss some architectural patterns at the end of the course. We will discuss some architectural patterns from this book, which is often called POSA, Pattern-Oriented Software Architecture. In Volume 1, the authors showed some architectural patterns that you can typically realize using the patterns of the Gang of Four. Also, there will be numerous examples and exercises that you can work with and try and explore possibilities. These examples and exercises come from various application domains. So the book of the Gang of Four mainly focused on user interface aspects, but in this course we will also look at more technical systems, more other systems like a spreadsheet, etc. So, in my opinion, an excellent learning mix. Now, what are the skills that you go home with, that you have improved during the course? Now, of course, you will have seen quite a bit of UML, have used UML, so your UML skills have definitely improved. You maybe know now more constructs in UML that you could use in your daily work. You have learned to recognize patterns. Now, of course, there is much more to learn there, so of course you should keep practicing this stuff in your daily work. Also, we have seen how you can combine patterns, and that's the fun thing. You can just play with them and keep adding them to arrive at an architecture. So you also have reasoned about architecture. You know why you have chosen an architecture, namely to realize some non-functional aspects that are required. And also, that's a byproduct, if you like, we will be able to reason about patterns and concurrency, a very important language aspect, for instance, in C++ and Java and other languages. Okay. But in particular, you will have had some fun, and I think that's very important. That's why we are here, to have fun. Thank you for your attention, and I hope to see you in one of the courses at the High Tech Institute.